Hi guys, good evening. So this will be a very short introduction to the concept of monads, right, in Scala and functional programming. So I have created some very short code snippets, and I just walk you through the simple basic understanding. So this is basically there is a concept of a effect in functional programming, right, which is called this is basically effect is basically an effect of optionality. So there may be some value. There is a box, right? This is, you can imagine this as a box, and there is some value in the box. So the box can have optionally a value, or it may not have a value. Similarly, there is a basically there is another box which is about concurrency, right? So this is the effect of some result, right, which will be available sometime in the future. So if we compare with our Elixir thing, right, this is very similar to the task abstraction that I think we all are aware of, right? And then there is a so these are the four code snippets I will describe. So this option, right, is a also a box. It's a effect, and it is also a monad, right? So what is a monad? So a monad is basically is a sequence. So very first thing is it is a sequence, right? And it is a sequence of effectful computation. So that's a very approachable definition. So what do we mean by these things? So this is a box, as I said, right? So there is some for comprehension kind of syntactic sugar, right, in defined in language. And if you hover on this thing, right, it will show you, or you can just say add type annotation. It will give the annotation as a hint. So basically, these are integers. So what I'm doing here is basically I am opening the this construct is opening the box, extracting the value, and allowing me to uh, do some computation with that value. So here I am just adding these three values, right, which are, I'm just pulling them out of the box, and again the result is basically enclosed in another box of the same type, right? So this is basically a very strongly typed language, just like Haskell, right? So it has a big influence, largely influenced by Haskell, and this is a option of int, right? So this is the effect. And then we just go, and there is something called as a this is, I think this will be a little new construct, because this comes from the object oriented world. So if we see, this option is also a object, right? So this is again the Java influence that is speaking for itself. So each in Elixir, right, we know we have a module, and we send some structure to it, and then we do something with that, right? So here it is basically this variable is an object, and then it has a, I'm calling a for each, right? This is a basically a higher order function. So what I mean by that is that this is taking another function, right, as a, and that is a basically this is a lambda. So I can write it like this. So I can say x, and then Elixir uses arrow, right? Here it is a little different arrow, fat arrow, right? That so I can just say here x, and if I run this, right, so I'm using IntelliJ IDEA, which has a great ecosystem around Scala, Java. They have tons of things, Python, right? They have Rust, they have JavaScript, they have Go, right? Goland is a very popular editor. So they have a lot of stuff. I have also used IntelliJ for some time for Elixir, playing with Elixir code. It was okay. It was pretty okay. but yeah, not as sophisticated as these things. So anyway, that is the thing. So we have the answer here. It is 6, right? So uh, we we have captured the optionality. Now what happens is, let us say I do, instead I do go and I say,
Atul,
yeah,
few people have raised hands. Can you?
sure.
I had a question. So this result option, it's a option. It's an option, not an array, right? Um, so how are we doing for each? For each is usually over arrays, right? I would expect that, but it seems like it's a single value, the sum of the three integers. So what is for each exactly doing here?
Okay, so for this is not a for each. It is basically something called for comprehension. Okay,
Yeah, I
and
mean the for each at the end of the,
okay,
14 line.
so
Yeah.
okay. So this is basically okay. I'll just give to answer your question. Let us do something like this. I'll give a b opt as a um, one second. I'll do it this way. I type a notation and I will say, just say none, right?
Also, you mentioned which one is module name here in this file?
So there is a module is basically, this is different from what Elixir has. At a high
Okay,
level, object is you basically enclose everything in the object, right? This is a singleton, which is fairly similar to what we use modules for in Elixir, right? But Elixir has all the data is transparent. I mean, there is nothing like the encapsulation, right? You can always see the data.
okay.
Uh,
What is line number one? Package playground.
Okay, so package is basically basically a way to structure the code, and
Okay,
this is actually you can put things together in a package. So there is a concept of visibility, right? So you can say that just make these objects or any other stuff I define only visible in this package. So if there is another package, so there is something called package protected variables, right? So we have that. We will cover that. This is just
okay,
really
okay.
a way.
Just still, a package is for a file or a whole application. Like just like one app can have multiple packages, or like how is
Yes,
it?
yes. One app can have multiple packages. Basically,
Okay,
but
can two files have same package?
no, two
Mm.
files have same package. Yes, yes, you can have. So let us say I'll go this you see my monad 1, 2, 3, and 4. They are all defined the same package. So
Okay,
the one thing is, if I want to use my monad 2, right? Let us say this. Let me do one thing. Well, key equal to my monad 2, and this is very much a valid syntax. But if I want to use from something from a different package, right, then I will have to do some imports and all that stuff.
okay, okay, okay,
Okay, so
okay,
this package is basically a
okay.
way to
Okay,
rest.
for now, I will assume it is kind of context for now. Let's now. For now, I will assume.
Basically, there is a separation of concern, right? That is actually
Okay.
term, right? So this is something around that. So you can have,
Okay. Okay.
yeah. So you can have a domain logic in a separate package. You can have services in a separate package. So it is similar to the layers thing that we do in Elixir, right? So
Okay. Okay. Can you open that file again? My monad one.
okay, yeah.
Yeah. And here, what is yield A plus B plus C?
Okay, so basically what's happening here is actually I these are three boxes, right? So we are okay.
Okay.
And now what happens is this is a monadic computation. So what we mean by that is that there is a sequence here, 9, 10, and 11. Okay, and you want to open these boxes for some reason, right? You want to do some processing with the content. So this
Yeah.
processing is just summing up the three numbers, right? So that is the
Oh, okay.
essence.
Okay. Okay. Now I get a better feeling. Like I'm just assuming like a pattern matching, and I set a value in the function, and I use it later for yield a plus b plus c.
Uh-huh. So pattern matching is also very popular. I mean, it is a major feature of Scala. So I will
Okay.
first show you this thing. I just run it again. So I have set it as none. So what I'm saying is there is optional, right? So it can either the value can be there or it is not there, right? So it is something is trying to capture that effect. So if I run this thing and if I just see the thing, I will not get anything, right? Because my result opt here is a none. Why it is a none? Because my second this b opt, right? This box is empty. So this complete thing has no meaning, right? Because I am getting a out of a box. There is nothing here, and then I am getting a C. Because there is nothing, the complete thing is nothing. So it is a basically a singleton. It is a none, right? So it is very similar to uh, Elixir has this is a basically a singleton object. Elixir, I am not sure, but this is a no op. I mean, nothing will happen, right? If you do
Okay.
that, right? Java, if you guys have played with Java anytime, right? It had a null thing, so it is very similar to our Elixir as right nil. So we return a nil, and then the nil thing anything, but you want to say that there is the absence of this thing, right? Let us say you are
Okay.
searching and then for some value, you can optionally say that the value could be present in the list or it is not present, right? So
Okay.
this
If
is
it was, if there was some value, then we will get a result.
result. Else you will get a none. So let us say there is a map. If the key is key value pair is there, and then the lookup will be successful, else it will return you a none, right? So this is a very typical example of that. So
Okay.
right, so this is the for each part. So the essence of monad is this thing that anytime anywhere, right, you have your box not defined, then we get a none. So it's basically a no op thing. Okay, any questions, guys?
So, like if the value of the option is none, then all operations on the options will be no op, like it will be ignored. Is that correct?
Yeah, because see, you have a at this point you are still okay, right? Because a is has value 1,
Hmm.
but now b has no value,
Right.
right? So this thing, it concludes that there is basically a concept of a this is basically a concept of a flat map and map. So basically this is a again a concept from Haskell that Scala has adopted. So there is no way, right? I mean, there is no way this computation can execute because you don't know what to do, what to put here,
Right.
right? So this the second example I will give on the same lines is a future, right, which has a effect of uh, a, a value that will be computed sometime in the future, right?
Right.
The value is not here right now, right? So it is a like a task thing that we have in Elixir.
Hmm.
So let us say this is a future. Now let me just close this thing. Let me firstly quickly run this. This is again a concurrency feature, right? Future, and when Friday or when I introduced it to the actor model in Akka and future, right? There are some very powerful things that we can do. But very shortly, a future is a concurrency primitive, right? So you see there is a package. Again, here this is a package, Sandesh. So all the
Yeah.
concurrent parts are basically in this package. Scala has multiple packages. One is this concurrent thing. So okay, now going forward, future is I have created 3 futures, and what I am doing is intentionally there is a I'm sleeping right for 3 seconds. So this is a millisecond thing, right? So this is a now this thread is basically we don't see that in Elixir because Elixir has a very high level abstraction.
Processes. Yep.
right? Processes, done servers and stuff like that. So we never deal with. There is no way actually you can work with the thread as far as I know. But this thing is a Java lineage where Java has a concept of threads, right? Which maps to always maps to one hardware thread. Meaning, let us say we have a hyper-threaded uh, machine, right, with 8 cores. So hyper-threading is 2 threads per core. So that is like 16 threads. So one thread will always map to one hardware thread, right? So that is the Java thing, and there is a lot of tons of basically research and very mature frameworks here. So this threading is this thread is basically something that we are talking about. So what we are saying is that this future is always executes. I mean, anything always executes on a thread, whether we see it or not. So this future, right, is a basically is scheduled to execute on a thread. So it is basically sleeping. Now this is essentially a non-blocking construct, meaning whenever this future is doing some very long computation, the future will basically be kind of taken out, and something else will be given the chance to execute, right? So there is a concept of a thread pool which they call as a dispatcher, and this there is a execution context, right? So these are the things we just assume that they are there. So yeah, going back to our monadic thing. So again, this is a monad. This future is a effect, and it is again a box, right? So now let us say we go to again we run this thing, and we run monad two. You will see that we have this effect of parallelism, right? So though I am sleeping for let us say three seconds, the total thing will run concurrently, right? So this is uh, a, B, and C, and then this thing will be pulled out of the box, and then we add that together. Now, what is the benefit of this? So the benefit is composition. So functional programming relies a lot on that, right? So you create very small parts and you compose them together. Elixir also has that strong theme, right? That we know. So what is the advantage? So advantage is, let us say I throw an exception, right? So while executing this, let us say this could be a database call, right? And this database call, this may be some network call which went through, database call which failed, right? And then another network call which is again going through. So what's happening is whenever I'm running, right, my this monad, because of this B thing failed, right? The future failed, and a failed future is equivalent to a none that we saw for the option, right? So this is a different type, but a failed future is none. So your first thing, right? Your first this one, right? This uh, first like this, because this is a no op, right? So this for each will not give anything. So I just run it and show. Something went wrong. So this thing came out, right? So if you see, I have given some identifiable string characters, right? So this is this never came, right? So, but if I instead just say thread sleep, and I say something like 22, right? Then what will happen is uh, 22 plus 3, 26. Right? So 26 came. This came because the box was okay, right? It had something, but exceptions again is a basically again exit also has exceptions. So it is basically you are saying that there is something unrecoverable happened. Let us say database can't be it is down, right? Database is down, or let us say your network API, right? REST API is the endpoint is not reachable, something like that. So that is the exceptional condition, out of memory or something like that. So these are basically exceptions, and these exceptions are you can't proceed further. So again, the value b here is not defined. So this complete computation results in an error, and the c, this part is skipped. So basically, there is the concept of a short circuiting here. So it is very similar to our Boolean conditions, right? Like a and b and c, like that. Where if b fails, then c is never evaluated. So this thing is actually what we do is at a very high level. Any questions, guys? Before I come to the design aspects of.
We are good.
Okay. So basically, there is a we always are striving when we write code for our system, right? Our what we are working on. We strive to come up with a reusable functions, which are again pure functions. And what we do is we want to compose them. So this monad is again a composition. So you are trying to create a bigger uh, something out of smaller pieces, right? And these pieces will be reusable. So we will, I think, there is the time or the background needs to be explained. But this is a very powerful concept because we have a lot of concurrency primitives, right? We do that every day. We convert that to a monadic thing. So downwards, right? They are all non-blocking stuff running, but at a higher level, you can still reason about this as a sequential program, right? So okay, so this is the thing we covered three.
Uh, I have one question. So for the this part on line 22, so it will wait for all the three futures to resolve, right? Like to it will await the result of all the three futures. Like after that, if all of them have succeeded, then it will unwrap it and uh, like add those values and wrap it again inside a future, and that's what we get on line 22, right?
Yeah, so that's a great question. So basically, what happens is this thing, right? The idea of a future is that it starts running right away. So the moment, let us say, you imagine the execution comes here, this guy has started running, right? So this is a so when you are here, right, all of your things are concurrently running. So your network call is happening, your database call is happening, another network call is happening, and you are basically saying that if all three of them are successful, then I want to take the three values and do something with that, right? So let us say A and C are REST API calls and B is a database call. It depends on the nature, but say let us say the logic is like that. Then this is the part. Now that's a I'll show another part where we create the futures. We create them inside, right? I mean, if we do some, it will be some method call here, but I have just done it for the simplicity's sake. So this future, now if you see my future, right? First future is sleeping for 3, second is sleeping for 3, and third is sleeping for 3, because they cannot run concurrently. Because what I am saying is that if this guy goes through, then only I want to start with anything with this, right? Else the short circuiting has to come into picture. So the total thing will be 9 seconds. And there is a main thread, right? Again, this is a Java lineage that main thread is, if it calls exit, then everything is stopped, right? This is a markedly different behavior from Elixir, where process isolation is very strong, right? A process can not affect another process. Linking. I'm not talking of linking. I'm talking of the any calls that it makes. So let us say a process goes down, right? The other process, unrelated process, will not get affected. But here, this is a Java thing where exit that gets called, right, will terminate everything. So I'll show that in Let us run this thing. Right. So basically, what happened is you were see the same thing I am doing in what's it?
No, can you open the old file again? Yeah, and
Okay.
just remove the line number 30 on thread dot sleep for 5 seconds. Is it? Yeah, just comment it.
Okay. This.
Like you said result is not printed because of this last thread, right?
Yeah. So what's happening is, see, there are two things now. These are three threads, right? I mean, three. You can think as three concurrent
Okay.
computers.
So okay, if line number 24 was not there, then it would have printed the result after 9 seconds. Is it correct?
No, no, no. That's so that okay. So let me show you one thing. So see what's happening here. This thing is required any which ways, right? But the effect is here because they're running concurrently. The thing overlaps, and then I have everything completes in 3 seconds, and then my this guy goes through, and this thing gets printed, and at the end of the 3 second plus let us say some milliseconds, this thing is reached. It sleeps for a while, completes the quorum of 5 seconds, and then the result is meantime printed. Uh, Here it is not like that. It is basically a sequence of the future. So this is essentially a non-concurrent. It's a purely sequential. The future is running, then only the next computation will be scheduled, and only after that is done, then the third guy. So even in this case, right? Let us say we comment here, we comment this one, and we run this thing. You will see nothing because the main thread is in Java, right? Is basically the parent, right? So there is nothing that comes. So this guy basically is, this is also running in a different thread because it's a future. This is also a different thread, and the main thread just basically schedules the three things for execution, and it quits. Now quitting basically is, it calls something called as the exit, right? And this is a complete thing, is a single process. So this is where Elixir and Scala Java they differ. I mean majorly, because this is a process here is a operating system process, right? There is a one-to-one correspondence. Whereas in Elixir we have a process is a basically an actor. So it is basically you can spawn 2, 3, 5 million processes, right? Which
Okay,
uh,
right.
is a very lightweight thing. So that part is very different, and there is a very strong isolation there. Here, there is a basically a bit of a connect here, and there are reasons because this model is a P threads, right, which came from C. So there is a lot of stuff which is rooted there.
Okay.
But yeah, the design is like that. So we will have to have this 5 seconds wait, and
Okay. Just question was like it did not print because Java has default. It has default of 5 seconds, and we crossed 5 seconds. We are using 9 seconds. That's why.
correct, exactly.
Okay. Abhishek has next question.
Yeah, Abhishek, go ahead.
Just to be sure, I wanted to ask that since in Elixir we can spawn processes, they're very cheap, but we should be careful if we are spawning processes in Scala or Java because they are OS threads and OS threads are limited. Is this understanding correct?
Okay, so that is basically what happens is a thread is a very expensive resource, right? So there is a something called as a pooling, right? I mean, we covered that pooling thing in Elixir, right? That last time talk. So there is a similar thing here, which is a thread pool. So the thread pool is, and there is a, these things are actually scheduled as a runnable tasks on that pool. So you have, let us say, whatever, 12 or 10 or 16 or 32 threads, right? That is what you have. But there could be a millions of these futures and actors. So that is the same thing. I mean, scale wise, it doesn't limit you. A very short answer actually.
Um,
Oh, okay.
yeah, one more question. So this on line 22 in this file where we are doing this A future, B future, and C future, it will wait for the futures to complete, right? For the value to be returned, right? So my question is that this waiting, this result future where this line of code from line 22 to line 26, this is happening on which thread? Is it happening on the main thread or some other thread? Like what I expect is this should block the main thread until A, B, and C are all done, right? So that's where I am confused.
Yeah. So basically, this is not happening on the main thread. This is happening on one thread, which is from this thread pool. Okay, so the thread pool, what happens the future, the abstraction it brings you it. Let us say this guy blocks, right? There is some heavy computation here, which involves maybe a lot of I/O, disk writes, database reads, writes, whatever, right? Those things. So what it will do is it will basically get out of the queue, right? And the runnable thing will be scheduled to run. So the
Okay.
idea is the threads should always be used. They should never be blocked, right? So there is a it is a very precious resource. So we have to be careful, and there are practices which get entered, right, when we write Scala code, more and more code. That these things are actually used to we design in a such a way that these concurrent things are basically. So to answer your question in a short, yeah, this is a different thread. This is not the main thread. Main thread is creating these three futures. It
Mhm.
just this guy is completely happening on a different thread. This is happening on a different thread because this is again a future, right? So this is not happening, and this is what is happening. So the main thread, we are telling
Okay.
that guy, please wait, right? I mean, because the other people have to uh, complete.
Okay. Now it makes sense. Yeah, got it.
Right.
Thank you.
Now, the thing is that day, what the question I had was this about the time thing, right? How long you wait. So this is just for illustration's sake. Libraries and frameworks in Scala, right? They return futures, and then they basically so HTTP response, right? And those things are basically the frameworks just return futures. So you don't think about this thing. I mean, you never have to think about this. Everything of that is managed, and you just write your business logic here, and you follow certain well-defined patterns, and you reap the benefits. That's the general trend how we
Yeah.
design.
Atul, I'm still confused. We have three futures in this file as well as that file, also three future.
Correct.
Then why is it waiting for sequence in one file and not waiting for in one file? They are running in parallel.
Right.
Man,
So okay. So what happens, Sandesh, is that let us say this A, right? So A is
yeah.
an integer, right? So what I will do is what I'll take this A and I will make it. I will let us say what is this A? A returning is 3, right? So I will say A plus 1, right? This is a valid syntax. And now here I will say A plus B plus 2, something like that. Now, what is this is that that let us say this future, till this future completes, I cannot even start executing this. This is the essence of the monad thing because you have a previous computation. If it fails, short circuit, you cannot do anything, right? But in this case, if let us say this succeeds, this step, and it returns an integer. So that integer is now being used in the pipeline. So this is essentially a pipeline. Yeah, we can think in terms of the Elixir's pipe symbol, right? The, that is a different thing, but there is some similarity. So the value of A is, if it is not there, nothing happens. Short circuit, failure is. But let us say it is there, then as till this guy completes, right, database call or whatever that happens is completes, you don't have the value of A. So there is no way you can start this thing. Now let us say let us go here and do the same thing, right? So let us say here B. Let me do that here. So picture of let us say I just want to successful, and then I say A plus 1, something like that. So now my A is 1, B should be 2, and C should be 3, right? So let me make it 10, A plus 10, something like that. So if I run this, now what will happen is, let us see that. So yeah, so this is given you 15, because what happened was the value of A is 1, right? It was taken. This is now 11. 11 plus 1 is 12, and this 3 is from C, that this box. So total is 15. So yeah.
Yeah, I was just saying that this looks exactly similar to the with clause in Elixir, the with clause where
Yeah,
we pattern match.
correct.
So
Exactly.
it's similar to that.
Yeah. So yeah, we have
Yes, like if something breaks in with, it goes to else.
yeah, exactly. Yeah. So the with thing is, yes, that's a great observation. That is what happens. But the thing is now the thing is, there is nothing like at least I don't know or anything like a box and effects in Elixir, right? It's a pretty straightforward kind of a thing. You compose things using pipes, and you make pipelines, but there is nothing like if this effect fails. I could not see, at least in my studies, whatever I have seen of Elixir.
What is
There is-
effect here? Which line is effect?
so future is an effect. So this, you are saying that these are two things, Sandesh. One is the it is a basically a box, and it is also effect, meaning you are saying that this is a effect of something happening in the future, right? I don't have a value, but whenever the value is ready, you will get it.
Okay, so AFUT is the effect.
AFUT is a, yes, exactly. Yeah, that's the effect. You're right. So if you get the type of it, it's a future.
Okay, so you were saying that in that other one we did not have an effect because we did not catch it in val. That's why they were running sequential. Is that?
So here,
Yeah,
here what's happening is
we do not have effect, right?
we have the effect. We have the effect, but see, as soon as you start this thing, right? I mean, if let us say, imagine the exhibition reaching here. By the time it is here, this effect has started running. So this future has started running. So it got scheduled on a thread from the thread pool, and it basically slept for. So that is happening in parallel, right? So it slept for 3 seconds, and it is ready with its value, right? And that is basically it's that value is ready for you to use. Now you come here, right? Now main thread is not waiting. Main thread has started, spawned off this thing. It comes here, it spawns of another thing, comes here, spawns of the third thing, and these guys basically actually go, and this they basically, there is a they queue up for the execution, right? So the queuing up happens, and the threads basically the thread picks up, right? Let us say it picks up a future. It sees that this guy is blocks, right? So it will basically, the thread won't block, the future will be basically it will be pushed to a wait queue, meaning wait queue meaning it has to complete, right? The database read has to complete. So till that time, it will pick up B future, and then similarly C future, and whatever comes first or whatever completes first, the result will be returned. So that is how what is happening. So net effect is that all these execution times overlap. So effectively, we are for all these things we are sleeping for 3 seconds, whereas here we are sleeping for 9 seconds, because your second future can't even start executing because it depends on this value which comes from the previous step of the pipeline. So that is the difference actually. This is the sequencing.
One minute. So are you saying is it only because of A is there in line number 14?
Yes, this is possible, right? Because you are saying that I want to take this value, I want to use it henceforward in any computation. So it
No,
could be,
no. Is it waiting only because of A? That's why it is waiting. Or if line number 14 was just 2, line number 14 was just some number.
right. So let us say this is let us make it as something like 2, right?
Yeah.
But basically, what happens is if you look at it, okay, I'll just this is for comprehension, right? It's basically a syntactic sugar. So what a syntactic sugar is that it is okay. I'll rewrite this thing. Let me do one thing. I'll do one result one one equal to a dot sorry a dot flat map. Okay, then this is my b, right? So this is a function. This is lambda, and then b dot sorry b view dot flat map, right? Uh, this is my C, and then I am saying C view dot map. And I will say A plus B plus C. Sorry, so this is A. This is B. Okay, this is my C. Okay, so this is my actually syntactic sugar. So let me comment this. Let me make it a feed. So if I run this thing, right? If I run it, let me run that. So right. So it is okay. Let me. This is failing, but let me change this thing to 2. Right, and let me run it again. Right. So this is the same thing I got. So if I just comment out this thing and I uncomment this block, and if I run again, I get the same result. So basically, internally, the compiler, Scala compiler, basically takes this snippet and rewrites it at this thing. 15, and if I do this, and if I say 10,
Line number 27, we had A plus 10. That's why.
A plus 10. Okay. Yeah. So yeah. So A plus 10. Okay, this is the we should return properly.
No, I think A. It was the value of B, no?
Sorry.
A plus 10 plus C.
Yeah, that was the value of B. You're right. So this should be A, like this, plus, and then we should have this one is actually it's B plus 10, like this. So if I run this-
B is A plus 10, right?
oh yeah, so B is actually you are right. So let me B is A plus 10. You're right. So yeah, so this is a 1 second. Now, okay. So okay, let me uh, redo the thing. The value of A is given here. Then the value of B is A plus 10, right? So, one sec.
I think instead of writing B, you can just write A plus 10 or no.
No. This is basically this is a transformation. So the flat map, right, is see this future is successful. Okay, I get it. So see, basically there is a this. Okay, we will have to do it like this.
I think the idea that
Map.
you wanted to say, I got the idea. Like instead of using that for comprehension, we are just showing what it does internally, basically, instead
Yeah,
of
yeah. So
that
this is
syntactical sugar.
correct. So basically, this is not. Let me replace this here. This is a basically a B pute, and we will get the correct result now.
Okay.
So if we run it like this, let me. Future of successful is a different abstraction. I will talk about that. So now here we get 6, and we get here again 6. So basically, this stuff is taken and it is rewritten as this one. Now going back to our question, right? See, flat mapping is basically is a glue, right? It is basically your tool to create the pipeline. So what happens is if this future is successful, then only you will get a value of A. If it is fails, if it throws a exception or something, short circuit, right? Because there is nothing it can do. The pipeline has no meaning. So this is exactly the same thing happening here, and that is what is happening here also. So this nature of the monad, right? That the future as a monad will hold, but the execution is overlaps or not is the key here. This here the execution is not happening overlapping because we have the compiler has no way to know, right, what this guy does. So it will just let this complete first, let this complete next, and that's why it will sleep for 9 seconds. Here it will do the same thing, but because the computations are spawned, right, they are not sequentially forked off. So this thing will complete. That is the difference actually. Hope I've given you the.
Okay.
Yeah, there is a lot of background here, but short of time. I mean, I can't.
Yeah.
Okay, so
Yeah, I
and
think it's like pretty, it's not very difficult to understand. I think like in the first one we are launching all the three futures at the same time, so they are all running together,
correct.
and by the time we are doing the sum, all the three threads which are sleeping, they are sleeping together. So and they are all sleeping for 3 seconds. So uh, altogether they are just sleeping for 3 seconds only, because they are all sleeping at the same time. But in the second example, we are launching the thread and immediately waiting for that. So we are launching the first thread, waiting for it for 3 seconds. Once we get back the value, we are launching the second one, again waiting for three
Yeah,
seconds, and
exactly.
we end up waiting for 9 seconds this way.
Exactly. Yeah. That's the right understanding. Yes.
Yeah, even I'm feeling I'm trying to relate. So it looks like a task when future is called. It
Yeah.
looks like a task.
Yeah. Future is a task. Yeah. That is there is a very close parallel with the Elixir thing.
It's like in
The
Elixir,
task.
if you launch three tasks and then you await all of them, and then want to add the numbers that they return. That's like the first example. And the second example, you launch a task, you await it, you get the value, you launch again another task, you await it, you get the value, and you do this three times. So there's no parallel thing involved, because you're launching and awaiting it. You're not doing like anything parallelly, right?
Yeah.
So
Yeah, the way it is structured is like that. So because you need this result, which can be used downwards, right, and given in this particular thing.
yeah.
So that can't be done till this guy completes. So whether this guy runs sequentially or whether it is overlapping, that is the only difference. And the task that async thing that we have, right, in the Elixir thing. So we do an await and all that thing. So this is very similar, but there is no awaiting specifically. This thing completes and the execution continues. Okay.
Okay.
Yeah.
So this is the yeah, this is the monad thing. So
Yeah,
yeah,
I found it interesting because I've seen this option and this none and some option. This I learned a bit of Rust, and I've seen Rust using this type of
yeah,
thing,
yes, yes,
options and all.
yeah,
Because what happens with this even happens with Elixir and many other languages. Like I work with Ruby and Java, and they have a lot of null pointer exceptions where you call something over null and then it blows up and crashes. But with options, what Rust does, and I think maybe something Scala also does similarly, is like if there's no null exceptions, there's an option can have a value or it can have none, and then it's like there's no null pointer exceptions because there's no concept of null. It's none or some value. So
yeah.
I
So
think
it is basically if you sorry, if I do it like this, right? Option of let us say none. So this is actually a none. So
okay.
any Java or anything that it interfaces, right? Uh,
And what might be the Elixir equivalent of option?
uh, I don't think there is anything. Elixir doesn't have. See, the close parallel I could see was there is a
Like what I feel is map dot fetch or map dot get, and where if the value is not there, we use a default value. Like I'm just thinking, I might be wrong or right.
actually the way, right, the Elixir allows you to do basically multi-clause functions, right, which is a
Yeah,
pattern matched on their arguments.
you can
So
have guards.
yeah, so let us say my list has nothing, right? So I give a special clause for that, and something with a head and tail, right? Something like that. So that is, I think, that concept is there, as I could understand, but it is not very क्या बोलते हैं, it is not a very apparent concept actually. So you can do the simple stuff. You can skirt or stay away from this problem in a different way.
Okay.
uh, like in object oriented languages, the problem is that it mostly, this null problem happens when you're calling something over a object and the object is null. So say you have some a number and you want to do number dot to string or something like that, and the number object is null, so or nil or something. So you end up calling to string over it, and it'll say null, you can't call null to string over null, and it'll throw an exception. But Elixir is functional. There's no concept of calling a method over an object.
Correct, exactly.
We
Yeah.
pass things to the method,
Right.
to the function actually.
Right.
And you can have guards in that function which says that if the argument is nil, then handle it, and otherwise do something else.
Yeah.
So I
Exactly.
think that's how they handle it.
Yeah.
Yeah.
That's how they handle it. Correct. Yes. So yeah, that is generally what I wanted to cover, guys.
Okay.
So any other questions? Yeah, just post them. Will answer that.
Can you just every screen for 5 seconds, one by one? Yeah, screen one.
I did not get that, Sandesh. What is that?
Monad 1 for 5 seconds, then open that Monad 2 file for 5 seconds, like that. One.
Okay, sure.
So we have file. Okay, next file.
Okay, I think this I need to check the syntax. Number 2 is this one. Monad 3 is so I'll just maximize this. Okay. I'll share them also if you want. I'll share them on the.
Yeah, just open 3 for a few seconds and then 4. We have it in video.
Yeah.
Yeah. 3. Okay.
Okay.